Hep, happy! Lesson time is here again. Lesson 5 is one of those lessons where you are in the driver's seat. Okay? What you'll be doing is you are going to create and you are going to analyze measurement questions. You're going to write your own questions. They do this one kind of backwards. They give you a tape diagram and they say, hey, come up with a question. I have to tell you, this is like my favorite thing. This really is, because it really stretches you a bit. You have to think about it in a new way, and instead of just always being, the one who has to answer. 5, 12, yes, Johnny, 17, oh, that's wrong. Instead of that, you get to write the questions. You're like, I know the answer. Figure it out. You can have somebody else answer it. All right, so let's do a little warm up here. There is a sprint. If you're going to do that, go ahead and do that. Converting, what do we have? Metric and customary length. All right, but we'll do some time conversion, because that was the last lesson there. 1 hour is how many minutes? 60. Yeah, 60 minutes. All right, so 2 hours then would be 120 minutes. Good. 3 hours. Yep, so do 6 times 3 is 18, times 10 slide, 180. Great. 10 hours. Okay, well, 10 times 6 is 60, times 10. Okay, 600. And now, similar question, how many seconds in 1 minute? 60 also, very good. So then 2 minutes, same thing, 120 seconds. How about 3 minutes? Same thing, 180 seconds. How about 10 minutes? Same thing, 600 seconds. Ooh, yeah, how about that? And now we're going to get into it. All right, so let's take a look at the first one. So you're given the tape measure here, and you are to come up with the question. So we have, this is 5 feet. Okay, and then we have this, which is 2 of those. And then the bracket and the question mark. Yeah, okay, so that's that we want to know all together, okay? It is fun to get kind of creative with these, but there's always a balance here. I've had students doing this kind of exercise where they get so creative, they write a question that makes absolutely no sense and just doesn't work. So definitely have some fun and be creative with this. But when you're thinking about, this thing is 5 feet, and obviously look at the second tape. Twice as long. Okay, so you're not going to be talking about how tall people are. Like Johnny is 5 feet and his mother's twice as tall. Nah, that's quite a mama there. All right, so when we look at something that might be 5 feet long, maybe someone else has something that's twice as long, okay? So we're going to create the question for the diagram, and then we're going to solve it. Ready? Let's do it. All right, let's take a look at this one. What would be something good that we could buy 5 feet of and twice as much? I don't know. Like licorice? Well, there's an idea. So let's say Devin's going to have a party, and he's going to get, what are the 2 most common kinds of licorice? Right, they're those ropes, and there's red and there's black. And what do most kids like more? Most kids, in my experience, prefer the red. See, so for his, what kind of party is he having? For his pig party. What's a pig party? You wish you knew. For his pig party, Devin is buying licorice ropes. His friends like black licorice less, so he bought 5 feet of black and twice as much red. How many feet? What are we asking? In all, okay. How many feet of licorice did he buy in all? And I should tell you, my normal handwriting looks nothing like that. It's writing on his tablets. All right, so anyway, hey, the math is easier, and the easiest way to do it is to just say 5 feet. Yeah, we have 3 of these blocks, right? So we can just do times 3, right? For a total of 15 feet. Okay, so he bought 15 feet of licorice. Ooh, that's going to be one happy little pig party. All right, let's go on and do another one. All right, and now in the next one, we have 3 tapes. All right. Now let's go to the bracket first. Okay, the bracket is saying all of it together, okay? Which is kind of nice because then we know, we're adding them up there. We're doing, it's not how much more, how much less. Although we have a little bit of that here. And having 3 tapes says, yes, we're comparing. So this is 6 gallons. Okay, so we're measuring liquid capacity, right? This one is, 3 of those. So this one is 3 times as much. And then this third one is 2 quarts more, right, than the 6 gallons. I mean, so you can, the math is not really supposed to be the hard part here, right? I mean, this is 3 times 6, right? And this is 6 gallons, 2 quarts. It just is. And then we want to put it all together. So think about something that makes sense for 6 gallons, all right? What could have one person have 6 gallons of, and another person is going to have 3 times as much? So we talk about milk and such with gallons, but unless you're running a restaurant, so if you're going to do some kind of like beverage that comes in gallons, which would not be soda, that's sold in liters, right? So this would have to be a restaurant having quite that much milk, or maybe it could be a restaurant at different times of day, for example, breakfast, lunch, and dinner, and whatever the beverage is, or it could be oil. I don't know, I mean, they deep fry a lot. Okay, so think about a liquid that somebody could conceivably have 18 gallons of, okay? Or maybe these are 3 different classes, and and how much milk they drink, or how much, I don't know, come up with something. That's what you're going to do today. So let's take a look at this and come up with something that works. All right, well, on this one, gallons, and then 3 times as much, and then the gallons with some quarts there, and we want to know in all. Well, I had said something about a restaurant and serving 3 meals a day, and how much. Now, what would they use 18 gallons of those, say, at lunch? What are people going to have a lot of at lunch? Well, that they would only have a little bit of, and then about the same amount at breakfast, and then about the same amount, a little bit more at dinner. I don't know, what kind of beverage would you serve mostly at lunch? Let's say soda. I don't really drink soda, but hey, maybe you do. All right, so we need a restaurant. Let's call it Chica's. Chica's Restaurant. Oh, Chica's Diner. You know why? Because it's a shorter word. Chica's Diner serves. Oh, and we can have them, actually, let's do this. We can have 3 different beverages, right? And then we want to know how much they serve all together. Okay, so 6. We'll just have to be careful in the wording because that's a little more complicated. Okay, so 6 gallons of coffee at breakfast, and 3 times as much soda at lunch. At dinner, they serve. Oh, let's go back to the coffee for dinner. Let's do something else. We'll do milk. How's that? They serve 2 quarts. We just have to be very specific in our wording here when you're doing different things. So I want to do one that was a little more complicated so you could see how complicated it gets and then decide if you want to do that. They serve 2 quarts more milk than, and this is where you have to be specific, than they had served coffee in the morning. Okay? Now, we can even be tricky and ask for the entire answer in quarts. Ooh, yeah. So, how many quarts, and now it's beverages, right? How many quarts of beverages did they serve all day? All right, and now we just have to solve this. So I'm going to convert it to quarts first, so that's going to be 6 gallons times, how many quarts in a gallon? 4 quarts per gallon. I'm going to write it that way so you could see. That's why we end up with quarts. So that's 24 quarts. Now how many 24 quart blocks do we have here? 1, 2, 3, 4, and 5. Ah, okay, so I'm going to do 24 quarts times 5. And you know how I honestly would do this? I would say 25 times 5 is 125. You would just know that. And then subtract the 5 and get 120. But you could also do it out like the regular multiplication way. 24 times 5. 5 times 4 is 20. 5, that's a 0 really. I have trouble with my zeros. 5 times 2 is 10 plus 2. Cross it out as you say it is. So then we get 120. Okay, so times 5. I'm sorry for the quality of my writing here. 120 quarts, but then we have the little 2 quarts there. Plus 2, that's a plus sign really, is total of 122 quarts. So they serve 122 quarts of beverages. That's good enough. We could say all day or each day or whatever. See, so that's how you can solve something like that. Well done. All right, and so, well, that's that. And then here is the problem set, okay? So on the problem set, now you're on your own. You're going to do your same thing. Solve for the unknown and write a problem using the diagram. Another one here with pounds and ounces. That first one, by the way, look back, was feet and inches, doing linear length measurement. Now this is weight in the customary system, pounds and ounces. Again, 3 tapes. Again, unfortunately, the bracket is nice and simple, the whole thing all together. You get the exit ticket. Notice you're not writing a question on this one. Isn't that funny? That's what you expected, but no, it's just, hey, this many feet, put them together. Pretty straightforward there. This one, they're asking you to draw a tape diagram and solve it. So which pretty much be, do the whole thing, read, draw, write, okay? And then another one, and another one, and another one. This one, though, is where you're writing the question. Of course, when you get to the homework, what do you do? On 5 as well. When you get to the homework, hop over to the homework time video, and I'll walk you through that soup to nuts, as they say, start to finish, alpha, omega, yeah. All right, well, look what you've gone and done. You've done another lesson. Kudos to you, and I will see you again. And next time, it is once again lesson time.